Hey guys, Mr. T here, just doing a quick video on natural logarithms and the natural logarithm laws. So Euler's number E, which you may have seen previously in your calculator, there's a weird button there, is a famous mathematical constant and a rational number. It's approximately equal to 2.71828, which I've rounded here, but like I said, being irrational, it has an infinite number of decimal places. Euler's number is relevant to logarithms because the logarithm in base E is called the natural logarithm. In maths, we use ln of x to represent the log in base E of our number of interest x, and call ln of x the natural logarithm of x. So ln is a shortcut for writing log in the base of E, interchangeable. You'll probably see this because it just takes less time to write. So, reminding you of how logs work, the log in base E of x represents the number of times you need to multiply E by itself to get the number of interest, which is x. Because the natural logarithm has a base of E, there's some interesting interactions between the natural logarithm and E. So ln of E is going to be equal to 1. ln of E to any power is going to be just that power, and then E to the power of ln of x is also the x in that power, ln of x. So as a result, basically what you see in these three situations is that E and ln cancel each other out. So let's do some problems here. Example questions that you might encounter. Find ln of E to the power of 3, wrong color, ln of E to the power of 3. You've got this law or situation, ln of E to the power of x is equal to x. Well, we have ln of E to the power of 3. So ln of E to the power of 3 is just going to be 3. Now ln of root E, we don't have a power here, but we can write it as a power because of the indices stuff that we've done before. Square root is the same as the power of a half. Now we have ln of E to the power of a half. So ln of E to the power of half is going to be 1/2. And that's a result of those laws above showing that ln and E pretty much cancel each other out. On top of those three things, all of the logarithm laws that we've covered in a previous video apply exactly the same to the natural logarithm. So you've seen these laws before. The only thing that I've changed here is instead of log A, etc., it's all natural logarithm. But when you're adding natural logarithm of two different numbers of interest together, it becomes the product of the numbers of interest. Natural logarithm, the product of number of interest. If you're subtracting, it's a division. If you're multiplying the ln of a number, that's the same as ln of that number to the power of m. So let's use some logarithm laws to simplify this stuff here. You have an addition of some natural logarithms here. So that's going to be ln of 5 times by 3, which is going to be ln of 15. Here you have a subtraction. So it's going to be a division, ln of whatever 24 over 8 is, which is equal to ln of 3. ln of 5 take 1. Now that's going to use one of the properties that we had above, because we know that 1 is ln of E to the power of 1, okay? You can imagine the 1 as this unknown. So 1 would be the power here, so we can write that 1 as ln of E to the power of 1. So rewrite ln 5, take ln of E to the power of 1. This is a subtraction. So it's going to be ln of number of interest in the first one divided by number of interest in the second one, which was E. ln of 5 divided by E, or 5 over E. Here we have multiplications. So 2 ln of 7 is the same as ln of 7 squared, and 3 ln 2 is the same as ln 2 to the power of 3. Because it's a subtraction, well, no, we'll do the powers first according to BEDMAS. So ln of 7 squared is 49. Take ln of 2 cubed is 8. Now, because it's a subtraction, it's a divide the numbers of interest, 49 over 8. Lastly, what we have here, 2 ln 3 is the same as ln of 3 squared. Now, much like we had here, the 1, we can rewrite this 3 as 3 lots of ln e, which is the same as 3 ln e is the same as ln of e to the power of 3. Ln of 3 squared, well, 3 squared is 9. Ln of 9 plus ln of e to the power of 3. And because it's an addition, you multiply the numbers of interest together, so the answer, or the simplification, is going to be ln of 9e to the power of 3. Chuck that in brackets. So that's a video on the natural logarithm. Some of the laws applied and some examples there. Hopefully that helps you out, and I'll see you in the next video.